Welcome back to this video lecture series on data structure and algorithms. Today we'll be learning about how to add a node in the circular linked list. So let's start. Well, we will divide this lesson in three parts. First we'll see how to add a node in the beginning, then how to add a node at the end, and then how to add a new node after a certain node. So let's start with adding a node in the beginning. The steps are very simple. First we have to create a node with the desired value. Then we have to make the pointer field of the new node to point the head node. We have to keep all other links unchanged. And then we have to make the new node as the head node of the circular linked list. Next comes adding a node at the end. For this, we first have to create a node again with the desired data value. Now we have to traverse the list until we reach the last node. Then we have to change the pointer field of the last node to point to the newly made node, and we have to make the pointer field of the newly made node to point back to the head node of the circular linked list again. And lastly, how to add a node after a certain node. For this we will follow these steps. First we have to create a node with the desired data value. Then we have to traverse the list until the node with that certain data value after which the insertion is to be done is found. After we found that node, we have to make necessary changes in the links so that the newly made node is inserted just after that desired node. Now in this process we can see that the user may ask to insert a node after the last node. For this case we have to first check for the condition that whether the node happens to be the last node, and then apply the same method for insertion at the end of circular linked list. So all of these will be explained very clearly when we jump onto the coding part. So here I have opened my IDE and I have already written down the code that I did for the singly linked list. So the creation is very simple. We just have to make a change here. In circular linked list, the last node is supposed to point back to the head node again. So I will do the same here. So the third next will be head. And here we will traverse the list. Now we have already seen the traverse list function for singly linked list. Now there are very few changes in this traverse list function for circular linked list. We have to create a demo node here, and in this case we have to run a do while loop where we have to check whether this demo node is not equals to head, and we will run this loop for that particular time only, and then we will do the same thing. So nothing that sort of different. Now we will do the insertions. So first we will see insertion in the beginning. So first we will ask the users to enter the data to be inserted at the or in the beginning. And here I will do a scanf %d ampersand value, and then I will use this function which I'll be defining later on, insert at first. I will pass the head node and the value of the new node, and then again I will print this message that now the circular linked list is, and I'll use this traverse list function. So now let us just define this insert at first function. So this function will have a return type of struct node star. The data types of these will be struct node star head and int value. So the first task is to create a node. So struct node star node is equal to we will use this function here, create single node. We have already been using this same function for many times, so I'll just get rid of this int part here. Okay, I'll also be needing a demo node here to store the head, because we have to do a traversal, and we'll do this here. We'll do the traversal using do while loop. So the condition in while will be demo next not is equal to null, a semicolon, and this will be demo is equal to demo next. Now, so we are inserting at first, right? So the new node here now will point to the head node, and now the head node will be this new node, and the last node has to point to the head node, and finally we will return the head node. So we have done this particular traversal in order to reach the last node. So now we will see insertion at the end. Okay, here insertion at the end. We will copy this part because almost everything is going to same, except that this will be at the end, and the function name will be changed. Obviously the definition will also be changed. So now we just have to define the function. So again, this will have a return type of struct node star. The head will be struct node star, and the value will be int. We will return the head, so let us just first write this. Also we will be needing these two lines because we have to traverse and we have to create a new node. So let's just copy and paste it. Okay, so now again we will traverse the list. The condition will be same again, demo next not equals to null, semicolon, and demo is equal to demo next. So now we have reached the last node, and here we have to add the node. So demo next is equal to the new node, and node next will be the head, and we'll return the head. And now we will see how to add a node after a certain node. So insertion after a node. We'll again copy and paste this part of the code, but here I will add another message that enter the node value after which you want to insert, and we will use a scanf here, and I'll use D. We had actually initialized we had actually taken this D, so this will be no worries here, and the name of the function will be changed, and we'll again pass an extra argument here. So the last thing to do is define this particular function. So let's struct node, this is the function name, and struct node star head, this will be int val, and this will be int d. We'll return the head as always, and again we have to do this, create a single node, and we'll also have to traverse it. So let's just do it. Now here we will first encounter the situation when if the user wants to insert a node after a node which happens to be the last node. for this special condition, the condition we'll be writing here is demo next not is equal to head and demo next data not is equals to D. Okay, so while doing this, I just remember one very important thing. I've done a slight mistake, but this can be a very important mistake. In all of these conditions, when we are running a while loop for circular linked list, the condition, this will not be null, this will be head, because the last node of the linked list is pointing back to the head again. So I'll make these changes, so this will be head again. And if we encounter any error, then yes, we may face for this particular reason only. So now coming back to this condition, so if the node after which we want to insert happens to be the last node, so this will be the condition, and then what we will do is we will demo next. Okay, this will be next is equal to the new node, and node next will be head. Now if this is not the case, then we have to traverse the list until we found this D. So if sorry, we have to actually run a loop here, a do while loop again, and the conditions will be demo not equals to null and demo data not equals to D. What we'll do is simply demo equal to demo next. Okay, I've done the same mistake again. This will not be null, this will be head, because this is a circular linked list. So I would also want you to not repeat the mistake, because this is a very crucial part here. So now here we have reached the node after which we have to insert. So now I will make again, I will be needing another node. Let's name it temp, because we have to save a link, and this will be demo next, and now this demo will point to the new node, that is the node is inserted just after node, and the next field of the node will have this link. Yeah, okay, so this looks almost okay to me. So we have to just run it and see whether we have done the right things or not. Okay, so there's no error for now, so let's enter the data as 1, then 2, then add 3. So let's say we want to insert 4 at the beginning. Yeah, it's been done properly, we can see. Now let's say we want to enter 5 at the end of the circular linked list. So yeah, 4, 1, 2, 3, 5. And lastly, we want to insert the node which will be having a data field 7, and after this 3 we want to enter it. So let's enter 3, and yes, it's been done properly. Now let us run it again, and let's see whether it can handle the case where we want to enter a node after the last node, for not that specific case. So let's just start 1, then 2, again 3. We will want to add 4 at the beginning, 5 at the end, and we now want to add 6, and we want to add after the 5 node. So yes, this is working. So this is how you do the addition of nodes in a circular linked list. Thank you for watching this video and staying with us. See you next time.